Okay guys, I'm going to do number 22 with you just because it was kind of confusing in class today. And I will tell you there will not be one like this on the test tomorrow. This fits a little bit better with the chapter where we learn how to combine distributions. But I'm going to go ahead and do it just real quickly for you here. So we have a situation at a large state university. The heights of male students who are interscholastic athletes is approximately normally distributed with a mean of 74.3 inches and a standard deviation of 3.5 inches. So we basically have mu sub 1, and I'll let that be the interscholastic. And this is actually the mean of the population. We actually know that. And then the standard deviation of the population is going to be 3.5 inches. So like I said, I'm going to let this be the interscholastic group, okay? And then the other population, the mean for the non-interscholastic is 70.3, and then the standard deviation is 3.2 inches. Okay, so these are our non-interscholastic. Okay, so I'm going to go ahead and just set up the problem, and I'm just going to say that the true difference between these two populations is known. We know it, okay? So the center of the population distribution for the differences is going to be when I take, let's just say mu sub 1 minus mu sub 2, and that's going to be equal to 74.3 minus 70.3, and I'm going to get the number 4. So we're dealing with a situation where the true center of the difference of the distributions is going to be 4. So I'm going to erase that just to kind of clear some things out here. So I have 4. And now under the probability that any randomly selected x bar is, or that the difference between any randomly selected x bars is going to be, if I'm subtracting interscholastic minus non-interscholastic, then that should give me a positive value. But I want to know, well, when would this be bigger than the non-interscholastic? So I'm really looking for when the probability of the differences from the samples is less than 0. So I'm going to be looking at this over here. So the way I subtracted is I said interscholastic minus non-interscholastic. And so if I'm looking for probabilities that the non-interscholastic is more, then I'm actually looking for negative values over here. So I hope that part makes sense to you. But basically, I'm just going to do normal CDF, and I'm using the normal distribution because I know sigma from from both populations. Sorry. So normal CDF, I'm looking for the area from negative infinity up to 0 with a mean of 4, and then this is where I have to combine the variances here. So I need the standard deviation, but first I have to find the variances. So I'm going to have 3.5 divided by the square root of n, and of course I'm going to square that, plus I'm going to have 3.2 divided by the square root of n, and let me put these in place. So my interscholastic had 10. So here n sub 1 is 10, n sub 2 is 12. So I get a 10 here, and I get a 12 there. So I have my variance of my sampling distribution of my x bars from the interscholastic population, and then I have the variance of the sampling distribution of x bar for my non-interscholastic. Okay, and this of course will simplify down to where I'm just squaring the numerator and then I'm dividing by 10 there, just like the formula we usually use. So doing that in your calculator, I'm going to get 3.5 squared, and then I'm going to divide that by 10, add to that 3.2 squared, divided by 12, and I get 2.0783, but I have to, that's the combined variance, so then I have to square root it to find the standard deviation for the combined distributions, and I get 1.4416. So now I'm going to go into normal CDF, and I'm going to do negative infinity and do up to 0. My mean was 4, and my standard deviation was the last thing that I found, so I'm just going to recall that 1.44-ish, and I get 0.00276. So I think that that's really the appropriate way to do that problem. You can get it if you do the 2-sample t-test because it uses all the same values, but it kind of gives you like the wrong area. So it's almost like you have to use the wrong direction if you're trying to use the test. But just wanted to kind of show you that. Like I said, don't worry about that tomorrow. It will not be on there, but I just wanted to show you. Now, be sure